in this final part of my survey of implementations of machine ethics, I'm going to take a look at some proposals that involve using machine learning. One of the key machine learning techniques to use is reinforcement learning, and it has a very natural map onto utilitarianism. So obviously in reinforcement learning, every time the agent takes an action, it gets a reward, and it tries to maximize its expected reward over time. And the techniques of maximizing reward give you quite a natural way to cope with things like uncertainty and to cope with time-delayed rewards. So in this paper by Abel, he proposes reinforcement learning as a framework for ethical decision making, and he looks at a couple of examples. And this specific example came from another paper where they were critiquing using rewards for machine ethics, but they were particularly looking at a situation where you didn't get this look ahead, so you couldn't add in a kind of discounted way the rewards you might expect to get in the future. So in the particular example, you can be in one of two worlds. In one of these worlds, cake is ethical, and in the other world, death is ethical. And there's a 50-50 chance that you are in the cake world and a 50-50 chance that you are in the death world. And you can take three actions. You can bake a cake, you can kill someone, and you can ask what is ethical in this world that you are in. And so here's the reward structure. If you are in the world where cake is ethical and you bake a cake, you get 1. If you are in the world where death is ethical and you kill somebody, you get 3, and otherwise you get 0. Now, if you don't have the kind of reinforcement learning mechanism for adding the rewards you'll get in the state that you end up in, then you've got a 0.5 expected reward for if you bake a cake, because there's a 50% chance you'll be in this world where you get a reward of 1, and you've got 1.5 reward for if you kill someone, because again there's a 50% chance that you're in this world where you will get 3 if you kill someone, and you get 0 reward for doing anything else. There's no incentive for the agent to try and find out which world they're in. But if you use reinforcement learning, for instance, in a very simple way where you don't even discount the future rewards, then you're allowed to say, well, if I ask and I'm in the cake world, then I will get a 0 reward for asking, but then I will know that I can get a reward of 1 for baking a cake. And if I ask and I'm in the death world, again, I get a 0 reward for asking, but then I will get a reward of 3 for killing someone. And if I ask, I can disambiguate those situations. So overall, my expected reward is 2. There's a 50% chance which world I'll be in, and then I'll be able to get some reward, whichever world I end up in. And so reinforcement learning will actually allow you to do this kind of sequence of actions to get you to the right ethical solution. Now, I think the first thing that you might see here is that in contrast to the symbolic AI kind of approaches that I was talking about in the previous video, where they were often asking about how do I encode this particular kind of ethics in logic, what you have here is how do I make a reward-based system, how do I make utilitarianism of some kind match the sort of ethics I'm interested in. And this one's just asking, how do I let it make me do an ethical action? But if we look at the next piece of work, which is this paper by Ecofé and Learman, Reinforcement Learning Under Moral Uncertainty, here they actually get different ethical theories to vote in order to determine the reward. And part of the reason behind this is that we know from philosophy that nearly all the ethical theories have what we would call pathological edge cases. So their idea is that if you actually pool the answers from all the ethical theories, then you will get the kind of more generally accepted ethical outcome. And you can also use this voting to give you a reward. So it's a way of sort of mapping the answers from a whole load of theories into a utility function that you can then use with reinforcement learning. So they do a case study based on our trolley problems, and so just in case we haven't covered this already, in the trolley problem there's a train whose brakes have failed, powering down the track, and there are 10 people tied onto the track. So if you don't switch the points, the train will run over these 10 people. If, on the other hand, you switch the points, you divert it onto another track where there's only one person, and so under, for instance, a utilitarian ethical system, you want to pull the switch and divert the train. But you might be in some kind of deontological world where, you're not allowed to deliberately do something that will result in someone's death. So in fact, pulling the switch there is unethical, and you should leave the train to carry on to run over the 10 people on the track. So if you have some kind of voting system here, then in this case, they're actually using the utility calculated by utilitarianism. So you get a minus x utility for killing x people, and you get a -1 utility for killing the one person, which results when you pull the switch. Meanwhile, deontology, which is more of a yes-no thing, it says, no, you shouldn't pull the switch, so you get a -1 there, and you get 0 otherwise, which is the situation where it runs over x people. And they also considered what they call boosted deontology, where because utilitarianism can do this kind of graded thing, and so it gets like 10 votes if 10 people's lives are at stake, the boosted deontology gets a much larger negative thing for something it says is unethical. So boosted deontology, you get -10 if you pull the switch, and again 0 if you don't. And below you can see some graphs that they've produced to show how, depending on which voting mechanism you are using and the number of people are on the track, how the system decides whether it should pull the switch, which is the orange bits, or do nothing, which is the blue bits. So this is a sort of proposal to take a whole load of ethical theories and bring them together into a utility function that somehow represents a consensus view among those ethical theories. The last one I'm going to look at is a slightly different idea, value-constrained learning. So this is going back to a situation where we're not using one mechanism to make all our decisions, so that we don't have ethics is every decision, but instead we are using ethics to constrain some underlying decision-making mechanism. So in here, you have a 2-stage learning process. And in the first stage, you essentially learn ethical constraints upon the world, and then in the second stage, you try and maximize some other reward. So you can see in this algorithm that I have taken from the paper, this first for each loop, that here the agent picks something, and then a teacher, an ethical teacher, assigns a reward based on how ethical the agent's choice was. And that allows the agent to develop an ethics-based reward function from the features in the environment to some policy. Then you go into a recommendations phase, and this is using a kind of recommender system, and it tries to learn the appropriate recommendation to give people based on some context vector. And this time, each time it makes a choice, then it calculates what to do based on a weighted sum of the reward that is predicted by the reward-based system and the reward that is predicted based on the previous ethical learning system. And then obviously it gets an actual reward, so it updates its recommender system, but it doesn't update the ethical system. So the ethics that it's previously learned continues to have an input into the choice that the system actually makes. And they've run some experiments and shown they get quite good results here. So this is a system where it's bottom up in learning the ethics, and then it uses those ethics to try and constrain the choices that are produced by another system. This idea of this kind of constraining ethical reasoning also appears in a paper by Laregia, and that they're using a more symbolic AI-based approach. But again, what they do is they compute a distance between the recommendation of the ethics system and the recommendation of the other system, and then try and have a threshold on the distance that those can be apart. So they try and find something that, as it were, achieves a compromise between the ethics and what the underlying system wants to do. And the Rossi and Mattei paper from 2009 surveys both these approaches to what they call ethically bounded AI systems.